Yes. Okay. So recall. So little bit. Then so last time we defined dot product, right? So if you have two vectors, so let's say a vector equals to a1, a2, a3, and b vector equals to b1, b2, b3, right? Then the dot product is defined the following way, that a1 b1 plus a2 b2 plus a3 b3, and also using dot product, and dot product has some properties, we listed those, right? And also define the angle. If theta is the angle between, of course it is geometric angle, a vectors and b vectors, then cosine theta is nothing but a dot b divided by norm of a and norm of b. So you can say, instead of saying norm, you can say the magnitude. Of course here we assuming that a is a non-zero vector and also b is a non-zero vector, because zero vector has no direction, so you cannot find out the angle of a vector with zero vector, because zero vector has no defined direction. Okay, Mayan, last time we did this, right? Right, these two formula, the dot product formula, and we also did the angle formula between two vector. Okay, okay, Mayan.
Yeah.
Right. So let me finish. I will take 15 minutes to finish the rest theory part. Then we start exercise. Okay, Mayan. Right. So let me tell you the rest theory part from here that we need. So see. So we'll see here the direction of a vector in space. Okay. Sometime that called direction angle. Direction. So the direction of a vector in space. We'll see how we can define the direction of a vector in a space. Okay. So let me recall you from the plane. So in plane what we have, the idea was basically in the plane we have two axes, right? X axis and y axis. Here x, here y, and they intersect at origin. So now when we had a vector from, let's say, O to A, the direction actually determined. How we determine the direction of this vector, A vector, let's say this is OA. We just measure how much angle it make with the positive x-axis. Right, man? So if A vectors equals to OA vector in a plane, right? So then to determine, then to determine to determine to determine the direction of a vector, it is enough to know angle theta, right? So how much angle it make with positive x-axis? if you know, suppose I give you a vector and I ask to draw it in the plane, xy plane. So you will start from the O point, but you don't know where you take the terminal point. If I fixed a angle, if I provide you how much angle it make with positive x-axis, then you can draw the terminal points, right? Okay, Mayan. So therefore, is it okay, Mayan?
Yeah.
So the direction of a vector in a plane is determined by the angle theta, where theta is the angle that the vector make with positive x-axis. If you are working in a plane, now what happened in the space? In the space, you have three axes, right? X-axis. So this is the case of the plane, right? So now let me tell you the case of the space. Now, if you working in a space, right? Then what happened? So in space, you have three coordinate axes: x-axis, y-axis, and z-axis. So maybe you can face some problem where you are working with many vectors. Those are not lying on the same plane. Few vector lying on a plane and few vector lying on another plane. But you have to work, with all those vectors. In that situation, you have to consider the whole space. You have to consider x-axis, y-axis, and z-axis. And now, so in this situation, if you want to determine the direction of a vector, so then it is little bit difficult. Why? Because in the space, we have three coordinate axes, or you can say that you have, the three plane, right? The xy plane, right? And then xg plane and zy plane, right? So now how it is defined? So see, the idea basically the same like edge plane. So you have the positive x-axis. So basically you have the unit vector along x-axis, you have unique vector along y-axis, and you have unique vector along z-axis, k cap. So okay, a little bit I have to come here in the plane that the theta was basically angle between x-axis, positive x-axis, and y vector. So in other way, you can say that theta is the angle between, you can say the between the vector a vectors and I cap. Right, man? Let me. Is it okay, man? Fine.
Yeah, fine.
Fine. Okay. So the same concept we will try to use here. That in space, space, if we take a vector, let's say it starts from O and end up at the point, terminal point, let's say A, you have the vector OA vector, then we try to find out the angle between I cap, J cap, and K cap respectively of A vector. So those angle we call the direction angle of that vector. So let me tell you here the definition. Did you understand?
Yeah, that's fine.
Okay, okay. So let me write here. So if you have, so the direction angle. So here it is. So you taking the x-axis, y-axis, this is x-axis, and this is x, this is y, this is g, and let's say you have a vector here starting from O and end up at the point A, and say this is A vector. Now this is your I cap, and this is your j cap, and this direction you have k cap. So alpha, this is angle between, suppose we assume here alpha is the angle between A vector and I cap. and beta is the angle between b vector sorry a vector and j cap, and let's say gamma is the angle between. So we are using alpha beta gamma, Greek word alpha beta gamma, to denote the angle of the vector a with I cap, j cap, k cap respectively, is the angle between a vector and k cap. So if you have a vector in a space, then you know that vector must create three angle with three coordinate axes. Of course, the positive, direction. In other way, you can say the vector A will make three angle alpha, beta, gamma with respect to with three unit vectors I cap, j cap, k cap respectively. So alpha, beta, gamma are called direction angle because these three angle determine the direction of the vector, direction angle. So this is the definition. And the cosine of those angle, cosine of alpha, cosine of beta, and cosine of gamma are called direction cosine. Now we see how we calculate, the angles and direction cosine of a vector. Oh, okay, Mayan, it's fine. These two term we will understand. Direction angle mean what?
Yeah,
The
fine.
angle, yes, that made by the vector A with unit vector I cap, j cap, k cap, and the cosine of those angle we call the direction cosine. Yes. Now we see how we find out the you know three direction angles and direction cosine. So this direction cosine has some properties. We'll see those. Okay. So before do this, so let me tell you one thing here. Observation. Let So here the calculation part. Let me write down here. Let let see one thing. Observe that man, that here basically if you calculate a vector, a is a given vector dot I cap, right? So what is this? This is how defined a vector dot a cap. So just let me write down here what we know. We know cosine theta equals to a vector dot b vector by the magnitude of a vector and magnitude of b vector. So you can write down a dot b equal to magnitude of a vector, magnitude of b vector, and cosine theta. Any question, mine, so far? I mean this expression about this.
No questions yet.
Okay, okay. So now we use this. So a dot b, how you can write? Yes, magnitude of a, magnitude of b, and cosine of theta. Theta is the angle between those two. So let me write here that expression. So a dot I cap, how it is defined? It is defined by a vector magnitude, right? And I cap magnitude cosine of the middle angle that we consider alpha, right? This alpha, right? Mine is clear because we assume alpha is the angle
Yeah,
between a
correct.
and yes, I yes. So what we get here? We'll get here a vector dot I cap, right? This is nothing but here the magnitude of a vector, and we know the magnitude of I cap is 1. So into 1 into cos of alpha. So what we are getting? We are getting that a vector magnitude of cosine alpha is nothing but a vector dot I cap. So this means what we are getting? We are getting cosine alpha because we are interested to find out the direction cosine. So cosine alpha is nothing but a vector dot I cap divided by absolute value of a vector. Okay, okay, Mayan, fine, got it. So far the calculation is okay. Hello.
Yeah, so far good.
Okay. Now let's say assume a vector has the component here. We can assume suppose a vector has component a1, a2, a3. We trying to write down using component. Then you know what? A vector dot I cap. This will be what? This is nothing but a1, a2, a3. The component dot 1, 0, 0. So this will be nothing but a1 dot 1 plus a2 dot 0 plus a3 dot 0. So we'll get here a1, right? So basically what we are getting, we are getting here that let me write here this situation that we are getting. So basically, so this imply that a vector dot I cap is nothing but the first component of a vector. So what we are getting, cosine alpha is nothing but the first component of the a vector. Then here the magnitude of a vector. Similarly we can find out cos beta cos gamma, right? Similarly what we get, cos of beta will be a2 divided by the magnitude of this, and cosine of gamma is nothing but a3, the magnitude of a vector. Is it okay? Fine, fine,
Yeah, fine.
very good. So if you have a vector equal to a1, a2, a3, right? Then you know then direction cosine, or you can say if the vector make angle alpha beta gamma with respect to I cap j with I cap j cap k cap, then cosine alpha cosine beta cosine gamma given by this formula. Cosine alpha equal to first component by magnitude of a, second cosine beta second component by magnitude of a, cosine gamma third component by magnitude of a. Should I ask a question? Should I give you an example here on direction cosine? Hello.
Yeah, you can ask.
Okay, so let's try this one. So here the question. So find the direction cosine and angle of the vector this. Find the direction cosine and angles. Angles mean those alpha beta gamma. And okay, one thing I forgot to tell you, that these alpha beta gamma are the standard notation. People generally use alpha beta gamma to denote the direction angle. Alpha, they use alpha to indicate the angle that make the vector a with I cap, and beta a vector make with j cap, and gamma is the angle that made by a vector with k cap, like that. And you know cosine alpha, cosine beta, cosine gamma, these are the, you have to calculate cosine of those angles. You can say that is the direction cosine, like that. So let's solve an example here. So find the direction cosine and angle for the vector, for the vectors. Here it is that let's say u vectors equals to given by. So let me write here a vector, because we use the notation a, 2 I cap plus 3 j cap plus the 4 k cap. Okay. One thing I forget to tell here also, that the direction cosine has a beautiful property that I forgot to tell you, that that is let me write here that it is here, that if you take square and sum of the direction cosine, you get 1. So if we take sum of the square of direction cosine, then we get 1. This is the property that satisfied by the direction cosine. Oh, okay, Mayan. If you take any vector, if you take the alpha beta, it is true because you have the formula cosine alpha is a1 by this, cosine beta is a2 by this, cosine gamma is this. If you square and sum them, then you know the numerator you get a1 square, a2 square, a3 square, a1 square, a2 square, a3 square, and denominators you get magnitude square. So that is nothing but a1 square, a2 square, a3 square. So numerator you have a1 square, a1 square plus a2 square plus a3 square. Denominator you have a1 square plus a2 square plus a3 square. Both cancel out, getting 1, right? So cosine alpha square plus cosine beta square plus cosine gamma square, therefore 1. Got it, Mayan? So this property.
Yeah.
Okay, nice. So now, so solve this example. So find the direction cosine. We'll try this one. Find the direction cosine and angle. We'll calculate angle later of this vector. So how we do this? So let me write here the solution. So I'm writing here. The angles are suppose angles are alpha, beta, gamma. The alpha, beta, gamma mean you will understand we are taking in that order. Alpha is the angle that made by a vector with I cap. Beta is the angle that made by with the j cap, and gamma is the angle made by the vector a with k cap, like that. In that order, we will take always. So then what we get? Then we get cosine alpha. Cosine alpha, we know the first component divided by. So let me write here. What is the magnitude of a vector? This is nothing but square root of 2 square plus 3 square plus 4 square. So what is this? This is basically 4 plus 9 plus 16, right? So this is square root of 29. Okay. So here we have to put the first component. So if you want, I can write here the formula. So here a1 and this. So this is nothing but the first component divided as square root of 29. What is cosine beta? This is nothing but the second component a2 divided by magnitude of a. So this is nothing but 3 by square root of 29. And what is cosine gamma? So cosine gamma is the third component and magnitude of this. So this is nothing but you are taking 4 by square root of 29. Okay, mine is clear. Is this fine?
Yeah, fine.
Okay. Now we calculate the angle. You have to use the calculator. So for example, if you want to calculate cosine alpha, then the cosine alpha equal to you have 2 by square root of 29. So alpha, how you get? You have to take cosine inverse 2 by square root of 29. If you use your calculator, you will get this is approximately, in the decimal 68.2 degree. Okay. And then, the beta, similarly, beta you get, similarly, if you do the same process, then beta will be approximately 56.1 degree and gamma will be approximately 42.0 degree. I'm not doing this. Using calculator you can do. Just you have to put this information on the calculator, and calculator will give you this angle. Okay, mine is clear.
Yeah, fine.
Very good. Okay. So this is the idea, how to find out the direction of a vector. See, if I give you a vector and I ask to put on a plane, you can easily put it if you know how much angle it make with positive x-axis. Just you put the initial point at origin. So suppose it is very much easy if you have a plane, because you put you have x-axis, y-axis, and if you know how much angle, so initial point you put here. Let's say you have a directed line segment and I ask to put it here. Suppose if I give you how much angle it make with positive x-axis, immediately you can put it here. First initial point, then you don't know terminal point where you take here. So you select that point, on the plane, that guaranteed that the vector make angle theta, that already the theta angle, like that. So if you want to draw the vector on a plane only, then it is enough to know how much angle it make with positive x-axis. But if you want to draw a vector in a space, I mean, if you have 3 dimension, you don't know, the vector where lies, which plane you don't know, the only you want to draw in the space, then you need to know how much angle it make with every unit vector, then you can draw it. Okay, so that's why we need to study the direction angle and direction cosine. Okay, fine, I think it's enough. Now we go to the next concept called the projection. So any question so far about direction cosine, Mayan, is it okay?
Yeah, so fine so far.
Okay, let me finish this part, then we start the next link I send, and then start the exercise. So now the projection. Okay. Right. So let me write it here, that down. Okay. So now we'll see the projection. So the concept of projection. Okay. So see, let's say you have a vector here. Sorry. So let me write down here a vector. Let's say we have a vector. You know, let we start from the O point and end up at A point. So let's say A vector equals to OA vector. And suppose we took another vector start from O and end up at B. So let's say this is B vector. So B vector is nothing but OB vector. Okay. Okay, Mayan, is clear this situation? We have two vectors.
Yeah,
This is
clear.
okay. This is A vector, and yeah, and this is B vector, right? We want to find out the projection of B vector on A vector. So we want projection of B vector onto A vector. So this means basically geometrically what we want? We want to draw perpendicular line from the terminal point of B vector on the vector on A vector. So let's say this point is M. Now O to M. So let M is the feet of perpendicular of B on A vector. Okay. Now see, OM vector is called, this OM vector O to M, that is called vector projection of B vector on A vector. It is denoted by, it is sometimes people write like this, projection of B vector here and O vector. Okay. Okay, man. The definition is very clear, right?
Yeah.
So you have A vector and you have a B vector. Let's say the angle between those two vectors is theta, and we draw perpendicular from B to M. Then OM vector we called, yes, projection of B on A, that we denote by this. Now we want to write down a formula for this. Okay, we'll write we will write formula for this. So projection of b over a. So this is nothing but OM vector. So you want to write like this. Projection, I mean the OM vector we want to write. Okay. So how we write this? So let me write it here. So I'm using this space because here we have a space. So we can use this. So how to do this? Basically, see, observe that one thing that, first observe that if you use the trigonometry, so from the triangle BOM, we get, so it is a right angle triangle, and the M angle is 90 degrees. So this is 90 degree because by we draw it is 90 degree. So then what we get? We get here that the OM, the vector magnitude, I mean the length of OM divided by OB vector magnitude is nothing but this is cosine theta. Right, man? Okay. The adjacent by hypotenuse is cosine theta, right? Okay. Hello.
Yeah.
Okay. Now what we get? We get here that OM magnitude, the magnitude of OM vector. Because see, to write down a vector OM, what we need? We need magnitude and unit vector along those. That vector. So magnitude is given by OB vector, magnitude and cosine theta. What is OB vector magnitude? This is B vector magnitude and cosine theta. And cosine theta how given? So it is the angle between A and B vector. So B vector magnitude and cosine theta is given by A dot B divided by B vectors mod into A vectors mod. Right? It is given by this way. Now this magnitude of B and magnitude of B will cancel out. So then what you get? You will get here A vector dot B vector divided by magnitude of A vector. Right? So OM vector magnitude, we are getting this. Right? Okay. Right? Got it?
Yeah.
Okay. Now what we are getting, that we are getting here basically, so OM vector magnitude is this. Now, OM vector will be what? OM vector is nothing but the magnitude of OM vector and unit vector. Here we have to write unit vector along OM vector. So this is nothing but, so I'm writing here. So OM vector is nothing but A vector dot B vector by magnitude of A vector, and unit vector along A vector will be what? A vector by A vector magnitude. So what we are getting? So basically projection of B along A, we getting this, that A dot B by A vector magnitude square of A vector. So this is the formula. Okay, Mayan? The formula.
Yeah.
If you want to calculate, yes, projection of B on A is given by A dot B, A dot A absolute value of magnitude of A square, then A vector. You write down there. Yes, this is the projection formula. Yes. And yeah, and this is called, M to B. I forget to write here. MB vector is called, sometime people call it is the vector component of the B vector. So this is called vector component of B vector. Okay. And this is a B vector orthogonal to orthogonal to A vector. So this vector, because this is the component of B vector that is orthogonal with A vector. Got it? If you know, see how you calculate a MB vector. MB vector, how you calculate? Just from here, right? MB vector you calculate by this, that OB vector minus OM vector, right? So MB vector is nothing but OB vector is what? B vector minus MB vector you calculate, that is projection of B vector over A vector. Right, man? Is clear?
Clear.
Okay. So if you have A vector and B vector, if you want to calculate projection of A onto projection of B onto A, you use this formula. And if you want to calculate the orthogonal projection or orthogonal, you can say the vector component of B orthogonal to A, you calculate, use this formula, B minus projection of B over A, B minus projection of B over A, like that. So okay, so let me send you new link, then we solve their exercise. Okay, the theory part we finished. There is no more theory. Should I send new link now?
Sure.
Okay, see you then in the new link. Okay.